So hey there, welcome back to another video of Aerospace Technology YouTube channel. And in this particular video, I'll be talking about this particular article that is written on spectrum.ieee organization.org. But the main news is China rescues standard lunar satellite. So saving the DROA and B safe spacecraft involved a cutting-edge astrodynamical flex. This article has been written by Andrew Johns, and I don't own any of the stuff. This is just I being the fan of this particular site, and I'm reviewing that article for you guys. So, saving the DROA and B spacecraft involved a cutting edge astrodynamical flex. This is how it personally look like. China has managed to deliver a pair of satellites into lunar orbit despite the spacecraft initially being stranded in low Earth orbit following a rocket failure using a mix of complex calculations, precise engine burns, and astrodynamical ingenuity. China launched the DROA and B satellites on March last year on a Long March 2C rocket aimed to send the pair into a distant retrograde orbit DRO around the moon. However, the rocket's Yuanzheng I-1S, that's the name of the rocket. Upper stage intended to fire the spacecraft into a transfer orbit to the moon failed, leaving the pair marooned in low Earth orbit. Little is known for certain about the satellites. They must be small given the limited payload capabilities of the rocket used for the launch and are thought to be for testing technology and the uses of the unusual retrograde orbit. DRO orbit could be handy for lunar communication and observation. Critically, the spacecraft's small size means they have little propellant, making reaching lunar orbit from low Earth orbit unassisted a very tall order. However, Microsat, the institute under the Chinese Academy of Sciences CAS behind the mission, got to work on a rescue despite the daunting distance. Having to replan that in a hurry must be a nightmare, so it's a very impressive achievement. That is being said by Jonathan McDowell, Harvard Smithsonian. So basically, this particular person has said this. What followed by was a 167-day long effort that first got the spacecraft out to well beyond lunar distance and then successfully inserted the satellites into the intended orbit. The operation included five orbital maneuvers, five further trajectory corrections to fine tune the satellite's course, and three gravity assaults from the Earth and the Moon. The first step was small engine burns at perigee, the spacecraft's closest orbital approach to Earth, which gradually raised the apogee. The farthest point of the orbit from Earth, once the apogee was high enough, a larger burn put the spacecraft on an atypical course for the Moon. From the Earth to the Moon, normally spacecrafts going to the Moon follow the simplest trajectory, so a so-called Ho-Man transfer that burns a lot of propellant to get moving and then uses another big burn to drop into orbit once the spacecraft arrives at its destination after 3 to 4 days. Instead, the Chinese took advantage of a chaotic dynamical region around the Earth Moon system to save propellant. The Japanese Haiten probe had been rescued using a similar approach in 1990s, but it was sent into a conventional lunar orbit. The calculations to reach DRO, a high altitude, long term stable orbit moving in a retrograde direction relative to the moon, would have been arduous. A small error will make you miss your target by a long way. That is again said by Jonathan McDowell. The astrodynamics of getting to the moon is already much more complicated than just Earth orbit missions, says Jonathan McDowell, a Harvard Smithsonian astronomer and space activity tracker and analyst. Involving so-called V capture and distant retrograde orbits is far more complicated still, and having to replan that in a hurry must be a nightmare. So it's a very impressive achievement. V capture refers to a celestial body gravitationally capturing a spacecraft without the need for a significant propulsive maneuver. This technique, crucial for fuel-efficient lunar orbit insertion, demands precise timing and fine trajectory adjustments, as McDowell explains. The way to think of these modern and fancy orbit strategies is that you trade time for fuel. It takes much longer, but you use less fuel. Once you get out of the apogee of the transfer trajectory, they don't say how far out that was, but I'm guessing over a million kilometers. You can change your final destination a lot with just a small puff of the rockets. But by the same token, a small error will make you miss your target by a long way. Slides from an apparent microsat presentation emerged on social media, illustrating the circuitous path taken to drive the spacecraft to lunar orbit. The Institute, however, did not respond to the request from a comment on the mission. DROA and B separated from each other after successfully entering their intended destined retrograde orbit. The pair have, according to US Space Force Space Domain awareness, orbits with apogee of around 5 lakh 80,000 kilometers. That's a lot of distance. Relative to the Earth on a perigee around 2 lakh 90,000 kilometers, while the Moon orbits Earth at an average distance of 3 lakh 85,000 kilometers, indicating a very high orbit above the Moon. So there the spacecraft are testing out the attributes of the unique orbit in testing technologies, including communications with another satellite, DROL, which was launched a month before DROA and B into low Earth orbit. Though not a major part of China's lunar plan, the country is planning to establish lunar navigations and communications infrastructure to support lunar exploration, and the satellites could inform these plans as well. So I guess that was it for this particular video. Hope you liked the video. If you liked the video, make sure to subscribe to the YouTube channel and share these videos as well. So signing out, that was it for this one. Thank you for watching.